Okay, up next, we have inverse functions. If y'all don't know already, inverse function is when the x and the y are flipped. Like the x inputs and the y values are flipped. So if you have x, y, if you have a table here, you have like 0, 1, 1, 2, 3, 4, right? The table of an inverse function of this look like 1, 0, 2, 1, 4, 3, right? They're just flipped. If y'all don't remember how to find inverse functions, you take, this is all review, so I'm going over really quick. But if you don't remember how to find an inverse function, you just flip the x and the y, and then you solve for y again. So if you have y equals 3x plus 2, the inverse would be x equals 3y plus 2. And then you would solve it, and you would get x minus 2 equals 3y, and then x minus 2 over 3 equals y. And this would be your inverse function of the first one, right? This is all review. I was just making sure you I'm just giving you a little refresher before we get into the actual calculus part. To find the derivative of an inverse function, right? An inverse function is written as f to the -1. This is how you write an inverse function. This is new because normally -1, we use it as the reciprocal, which would be like 1 over x, right? If we have x at -1, we have 1 over x, right? That's not the same thing as f -1 of x. This just means inverse, so you just gotta know that. So the formula for deriving an inverse function is 1 over f prime of the inverse of f of x is the formula for the derivative of the inverse function. So if I have f, oh sorry, this is -1. If I have f -1 prime of x, right, or the derivative of the inverse of a function, this is the formula we use. We use 1 over f prime of the inverse of f of x. This formula is very important. You have to memorize it every time you do this problem. But once you have this memorized, it's really not hard at all. So if, for example, we have this function right here, and we have to find f -1 prime at 7. So what does this mean? It means you're finding the derivative, the inverse, at 7, right? So the first thing we have to do if we're using this formula right here is find the derivative of the function, which you derive as normal. So f prime of x equals 12x squared plus 4x plus 14, and the 7 here just goes away, right? So this is your derivative function that we're going to use to solve this. So then, once we have the derivative function, we have to find what goes inside of it, right? The inverse f of x. So at 7, if we're finding the inverse of 7, right? That means we're trying to find where the y value would be 7 in our original function, right? Because that's going to be the x value of our inverse function. Remember, because on the table, if we have x, y, we have 7 something, then the inverse is going to have 7 and then something on the other side, right? So we're trying to find what this is that gives you 7 to plug it into our inverse function as the x value. To do that, we're going to look at our original function here, and we're going to see, okay, what makes it equal 7? This case is pretty easy, right? Because just plug in 0, because 0, 0, 0, 0, 0, because all these x's, you would have 4 times 0 plus 2 times 0 plus 14 times 0, and at the end just plus 7, right? So in this case, your value that you're going to get is x equals 0. Because in this original equation, when x is 0, y is 7. So then, in your inverse function, you're looking for when the x is 0. So the inverse of this function, when f equals 7, this inside part right here, this part is 0, right? Because we plug in 7, we try to get 7, you get 0. So you have 1 over f prime of 0. And this is the new formula that you're looking for, because you replace the inside, you replace this part over here with 0. So to solve this part, you're plugging in this 0 into this derivative function into f prime. You're looking for f prime of 0, so use the derivative f prime function, right? So you have 12 times 0 plus 4 times 0 plus 14, right? So f prime of 0 equals 14. So your final answer here, you're going to replace this with 14. So your final answer is going to be 1 over 14. There aren't a lot of inverse problems on the exam, but as long as you know the basics and you know this formula, you should be good. If it's not as easy as this one where you could just look and see, okay, 0, 7, right? You could find the inverse function by switching the x and y like I told you and then solving that out, but that does take a while, so that's just kind of unfortunate if you get one of those. But yeah, that's it for this. We're going to move on to trig functions, trig inverse functions.